I'm Dr. Pinu. In underground cable engineering, the second topic in the second unit is basic dielectric theory of cables. This theory explains how the insulating materials, that is the dielectric, within a cable prevents current leakage and stores electrical energy by withstanding electrostatic forces and undergoing polarization when a voltage is applied. Dielectrics are poor conductors of electricity that are essential for isolating conductors and ensuring proper signal or power transmission. The dielectric of a capacitor is represented in this diagram. Principles of dielectric theory in cables. Insulating nature. Dielectrics do not allow the flow of electric current, making them excellent insulators that prevent short circuit and ensure current flows only through the intended conductors. Second one, polarization. When a voltage is applied to a dielectric material, its bonded charges slightly shift from their equilibrium positions, forming electric dipoles. This phenomena is known as polarization, which creates an internal electric field that opposes the external field, thus reducing the overall electric field within the dielectric and allowing for energy storage. What is meant by potential gradient or dielectric stress? Under operating conditions, the insulation of a cable is subjected to a electrostatic force known as dielectric stress. The stress is essentially the electric intensity or potential gradient at any point within the dielectric. What is meant by dielectric strength? It is a maximum electric field intensity a material can withstand before it breaks down and allows the current to flow through it. High dielectric strength is crucial for reliable cable insulation. Dielectric constant or relative permittivity. This property measures how much the material weakens the electric field compared to a vacuum. A higher dielectric constant indicates a material's ability to store more electrical energy. Energy storage. The ability of dielectric to polarize and store electrical energy is critical in applications like capacitors and certain types of transmission lines. Types of dielectric materials in cables: impregnated paper, metal paper, polyvinyl chloride, polyethylene, cross-linked polyethylene. The selection of dielectric material depends on the factors like desired current carrying capacity, reliability, lifespan, high temperature operation, and mechanical strength. Electric field and voltage. Current flow is charge in motion. If we neglect the conductor diameter, there are electric field of lines represented by circles of diameter such that the center of the circles are on the zero line and each circle passes through the center of the cylinders. This diagram represents the electric impact of electric field and voltage. Insulated conductors. A metallic conductor suspended from insulating supports surrounded by air and carrying electric signals or power may be considered as the simplest case of insulated conductors. Air is not a very good insulating material since it has a lower voltage breakdown strength than many other insulating materials. It is low in cost, and if space is not a constraint, then it is a widely used dielectric. This diagram represents our insulated conductors. Insulating is used to save space. Space is a common constraint that precludes the use of air as an insulator. Let us consider why some of the air surrounding the previous conductor is replaced with a better insulating material like dielectric. The distribution of voltage from the conductor to the covering surface and from the covering surface to the ground will be in proportion to these impedances. This diagram represents the significance of insulating to save space. What is meant by rising voltage? Related to the metallic conductor that is covered with an insulating material and suspended in air. When the ground plane is brought close or touches the covering, the electric field lines, recognizing that equipotential lines are perpendicular to the field lines, the bending results in potential differences on the covering space. This diagram represents how the rising voltage impacts insulation sheet. Barring surface irregularities as the conductor or ground, the electric field lines would be straight lines taking the shortest path from the conductor to the ground, and equipotential lines would be concentric cylinder around the conductor. This form a cylindrical capacitor and would make the most effective use of dielectric.